under the brace of NPTEL IIT Madras. In the last lecture we discussed about corrosion protection methods as applicable to concrete. This lecture also will discuss furthermore methods of how to treat concrete or any metal surface which is susceptible to corrosion. So, we will talk about corrosion protection in detail and corrosion prevention methods. There are different ways by which corrosion can be prevented. 1, you can condition the metal surface. 2, you can condition the corrosive environment. 3, can control the electrochemical reaction which is responsible for corrosion. Let us see one by one in detail of all the 3 steps or 3 methods by which I can prevent corrosion. The principal aim behind any corrosion prevention or protection method is that fight corrosion with corrosion. It means if you got to actually reduce corrosion, create a member or an element or a metal surface which you are sacrificing as a corroded member and then protect the member which you want to protect in the offshore structure. So, fight corrosion with corrosion is a very important underlying theme as far as corrosion prevention methods are generally adopted for marine environment. Let us quickly look at the first component of how to prevent corrosion, how to condition the metal surface. I can coat the metal or I can make an alloy of the metal. In both cases I will be able to retard the rate of corrosion, or I can at least prevent corrosion to a larger extent. When I talk about coating the metal, all chemicals and composites and adhesives cannot be used to coat the metal because they may have negative impact on the environmental assessment or environmental impact on the sea environment. Let us quickly see how do we apply the coating on the metal and what are the different material which can be used for coating the metal surface. For example, you can use another metal to coat an existing metal surface. In case commonly used are zinc or tin coating. They are generally applied on steel as an external coating surface. A protective coating therefore derived from the metal surface itself can also be applied. For example, you can treat the metal surface of a member using aluminum oxide coating. Alternatively, you can also do organic coatings like resins, plastics, paints, enamel, oil and greases. So, ladies and gentlemen, the first part, how do we protect metal to prevent corrosion, is that condition the metal. In that case we have a first alternative as coat the metal. So, we can either use any other metal surface to coat it like zinc or tin, can use a protective coating like aluminum oxide, or can simply apply resins, plastics, grease, paints, enamels etc. on the member surface itself to apply as a coating which can protect the member from corrosive environment. The second methodology by which we said is alloying the metal. So, you can alloy the metal to produce a more corrosion resistant alloy. There are significant examples available which we will discuss now. For example, stainless steel is a very classical example of corrosion protection alloy, which is an alloy of ordinary steel with chromium and nickel. So, this alloy of chromium and nickel improves the conditioning of the original steel and makes it corrosive resistant. Let us quickly look at how to condition the corrosive environment. There are 3 components of corrosion prevention. One is condition the metal, 2 is conditioning the environment which is responsible for corrosion. You can do by 2 ways. One is removal of oxygen, or you can use what is called corrosion inhibitors, which can also help to condition the corrosive environment to a greater extent. Now, when we talk about use of corrosion inhibitors, then you can use anodic type, cathodic type, absorption type and mixed variety of these 3. So, let us talk about how to work on depletion of dissolved oxygen content, that is removal of oxygen. As we all understand, ladies and gentlemen, presence of oxygen is a very important component which is responsible for active corrosive environment. So, if you reduce the content of dissolved oxygen in the sea environment, it can help me to prevent or to protect the metal surface from actively getting corroded. Oxygen is one of the main component which is required to activate the process of corrosion. Removal of oxygen therefore can help us to prevent or retard or to protect the metal surface from corrosion. Removal can be achieved by strong reducing agents. For example, can use sulfides which can reduce the presence of oxygen content in the sea environment or in the environment which is responsible for corrosion. This treatment of course is not advisable in open environment because abundance of oxygen is available in the open environment. Therefore, it will not be effective if you use sulfides to reduce the oxygen content in the environment. In a closed environment, this treatment can be effective, which can be used to achieve depletion of oxygen, dissolved oxygen content. However, this cannot be used in open sea state. When we talk about protection, we have many varieties and options available to protect a material from corrosion. Let us say marine atmospheric zone is one zone where the corrosion is not very severe, but it is marginally high. So, we can use coatings as we saw in the last lecture as well. In the immersed zone, I can use what I call cathodic protection. We will see this type of protection in detail in this present lecture. When we talk about splash zone, where the corrosion rate is very severe, I can use Monal 400 or cladding. I can use an external surface material as Monal 400 to be covering the existing material or the member and protect the member by this external cover. I call this protection layer as cladding. So, let us talk about more in detail on protection applied to splash zones. You may wonder why we are focusing on corrosion prevention and protection more on the splash zone. The essential reason is that corrosion rate is extraordinarily high in the splash zone. It is approximately double to 3 times as that of corrosion happening in the atmospheric and the immersion zones. The foremost option what people generally use in protecting a member in this splash zone is Monal sheathing. Monal is an alloy 400. Monal alloy 400 usually is available in 18 gauge thick. 18 gauge thick is approximately equal to 1.02 millimeter in metric units. It is attached to the tubular member in the splash zone. Remember, ladies and gentlemen, providing this kind of treatment of protection by putting an aluminum or Monal sheathing will not be helpful for the entire length of the member. It is effective only in the splash zone where the corrosion rate is the maximum. So, Monal alloy 400 is a common practice which is being used as a sheathing which is attached to the tubular member only in the regions of splash. It is done either by bonding, simply fixing the Monal sheathing by an adhesive on the parent member, or you can also weld this sheathing Monal alloy 400 to the parent member. There are principal advantages of using this as a protection for the primary member in splash zone. Monal alloy 400 has a very high modulus of elasticity, and this gives me a great advantage because it is suitable for field applications. As we all understand, when the offshore platforms are installed in site for field installation, you will see that extra forces because of erection and commissioning of these platforms will play a critical role in designing these members. So, Monal sheathing 400 will not get damaged or under the stresses which are caused because of this installation process. However, it has got couple of disadvantages. Since it is a light gauge material, the thickness of sheathing is approximately only 1 millimeter. It is very light, therefore it is vulnerable to get damaged because of tearing or impact forces. So, one has got to be very careful that the impact stresses should not be caused on the sheathed member, especially in the splash zone during erection or commissioning, and there is a tendency that this may even get teared off because the thickness of the sheathing is very thin. There is a tendency that the sheathing may even peel off or tear off from the parent surface of the material. The other type of metal sheathing which is generally done is austenitic stainless steel type grade 304. It is again an alloy of chromium nickel stainless steel. They are also wrapped in the splash zone over the members kept in the splash zone. It gives necessary corrosion resistance to the parent member by wrapping this austenitic stainless steel type 304 on the parent member. There are specific advantages of using this kind of monal sheathing or this kind of sheathing on splash zone. The advantages are it is having a very high degree of weldability and very high stiffness. The other alternative material which is also commonly deployed in the splash zone to protect members is copper nickel alloy of either 70-30% distribution or even 90-10 composition. This gives an adequate stiffness for the material or the member during installation, which is required and demanded from the members during installation process. The alternative material which is also used for corrosion protection of members in splash zone is you can use steel wear plates. Steel wear plates are used with a thickness of about 6 to 13 millimeter. They actually add strength and stiffness to the members. They provide greater impact resistance on the members. They are mainly used in high velocity silt laden environment in the sea. It protects member from anticipated erosion principally due to ice. Therefore, in Arctic regions or in isolated regions where the temperature variation can be very large and the temperature can go to sub-zero or formation of ice, this kind of corrosion protection methods are generally advisable to members near the splash zone. Ladies and gentlemen, alternatively another material which is also used to protect members in splash zone is rubber. Splastron or a vulcanized neoprene are two varieties of rubber products which can be used as a sheathing layer on the members or on the material surface near the splash zone. An elastomer rubber sheathing which is called a splastron is a very common phenomena being tried in brazing sections. It is highly resistant to corrosion and also to mechanical abuse. It is having a very high tearing strength, and once the rubber coating or the rubber sheathing gets hardened, you will not be able to tear it off so easily. It adheres to the parent material very strongly and try to become or have a tendency to become an homogeneous material with that of the parent member. The thickness usually varies from 5 millimeter to 13 millimeter, which is substantially high compared to monal sheathing which is hardly only 1 millimeter. The other alternative which we saw in maintaining corrosion protection is that corrosion inhibitors. I can also use corrosion inhibitors to maintain corrosion preventive environment in sea states. These are nothing but chemical additives. When they are added to a corrosive aqueous environment, it interferes with the chemical reaction and reduces the rate of corrosion happening on the members. There are anodic inhibitors, cathodic inhibitors and so on. Anodic inhibitors actually interferes with the reaction taking place at the anodes. As the name suggests, cathodic inhibitors suppress the cathodic reactions happening on a bimetallic couple. Adsorption type corrosion inhibitors generally forms a film on the surface of the member and physically blocks the surface from the corrosive environment. Ladies and gentlemen, corrosion inhibitors are very commonly deployed these days on deep water platforms, in particular in immersion zones and splash zones. Anodic inhibitors are more popular amongst all of these three types. Of course, you have got a mixed type variety as well, which is a combination of these. You can also control the electrochemical reaction happening, which is also responsible equally for a corrosion process. Electrochemical reaction control is a technique which controls the rate of corrosion reaction. It is usually done by passing an anodic or a cathodic current inside the metal. If you talk about cathodic protection, which is a very important and very common and very popular method of corrosion protection which is happening in most of the members installed in offshore or sea environment, cathodic protection in principle can be applied to any metallic surface or any metallic structure which is of course in contact with bulk electrolyte, and this condition is automatically fulfilled as far as offshore structures are concerned, because the electrolyte present is nothing but the sea water which is also having lot of sulfates and chemicals inside, which acts as a massive volume of electrolyte which is present. therefore the members are in contact with a high bulk volume of electrolyte. Therefore cathodic protection, ladies and gentlemen, is considered as one of the very common method of corrosion protection technique on offshore steel members which are generally employed in sea environment. Main use of corrosion protection method is to protect steel structures buried in soil or in immersed water. Remember, the basic requirement of a cathodic protection to be applied to a member is that the member should have a bulk contact of electrolyte. Therefore these techniques cannot be deployed in splash zone and tidal zone where there is an alternate wetting and drying taking place. So it is successful for immersion zones alone. As we all understand, immersion zone ranks second in the rate of corrosion in the whole length of the member, varying from atmospheric to the mud line level. So immersion zone has a comparatively good corrosion rate in comparison to the atmospheric level, but of course it is lower than that is happening in the splash zone. Cathodic protection is one of the common method deployed for members in the immersion zone. Remember, it is very important to understand that this technique cannot be used to prevent atmospheric corrosion. Let us quickly look at the anodic and cathodic reaction on a metal surface. If you understand this, it becomes easy for me to reply how do we go about cathodic protection. Look at this figure. I have got an aqueous solution which is an electrolyte which is present in a bulk volume here. I have got a bimetallic couple formed in the same member or a different material which I am using. One is what is called an anodic reaction, other is a cathodic reaction. Anodic is termed as anodic because it releases electron and becomes positive, whereas cathodic receives electron and becomes negative. This is what we have understood, that the one which releases gets anodic, therefore anodic part keeps on getting corroded. That is why we call this as cathodic protection technique. It is very simple, ladies and gentlemen. The material which I want to protect has to be made as a cathode, and the material which has got to be sacrificed should be made as an anode. Therefore we call this as cathodic protection technique. Let us quickly look at what is the principle behind the cathodic protection works. Now the steps are very simple. Connect the external anode to the metal to be protected. As I clearly said, the metal which you want to protect should become a cathode, therefore you require an external metal which is going to become an anode, which is ready to release electrons in a chemical reaction, should be connected to an anode, pass an electric DC current so that all areas of the metal surface become cathodic completely and therefore do not corrode. So the metal surface which I want to prevent from corrosion should be made voluntarily cathodic by creating an artificial metal once again in the same medium which is made as anodic. Therefore anode keeps on corroding, which I am sacrificing to protect my cathode, which is my principal member of an offshore structure. The external anode which is provided now may be a galvanic anode, where the current is a result of potential difference between two metals. It can form what we call a galvanic couple as well, or alternatively can use impressed current anode, where the current is impressed from an external DC power source on the metal. The cathodic protection can be achieved in two methods. One can use galvanic anodes, which we call as sacrificial anode technique, or can use impressed current method, which we call as impressed current technique. Let us look at the sacrificial anode or galvanic anode technique first. The galvanic anode systems employ reactive metals as auxiliary anodes that are directly connected to the steel which is to be protected. So the member or the steel surface which I am interested to protect should be made as a cathode, and I am introducing an additional member which is a galvanic anode system which is made as deliberately an anode. The difference in the natural potential between the anode and the steel, as indicated by the relative positions in electrochemical series, will make the material which is introduced now as anodic, and therefore corrosion will start take place with this metal. It makes a positive current flow in the electrolyte from anode to steel, which results in corrosion of anode, and that is how your principal member, which is cathodic, gets protected. Thus the whole surface of steel which is cathodic now becomes more negatively charged, and therefore they become a cathode automatically, and they get protected. That is why this method is addressed as cathodic protection technique in the literature. However, in this method I am using a sacrificial anode, therefore people use this as sacrificial anode technique of cathodic protection as well. The metals commonly used as sacrificial anodes are aluminum, zinc and magnesium. Now the alternate method by which you can also use cathodic protection is that you can use impress current to pass on the metal. The impress current systems employ either 0 or low dissolution anodes and use an external source of DC power to impress a current from an external anode on to the cathode surface. The connections are similar for application of cathodic protection to the metallic storage tanks, jetties, offshore structures and reinforced concrete structures. So cathodic protection method by impress current is also one of the popular method which is being used on members in the immersion zones. Here is a picture which shows you a cathodic protection technique using an impress current method. Here is a steel pipe which I want to protect and which I want to make as a cathode. So the anodes which I am going to introduce here is a sacrificial anode technique which I am going to create, which is usually from a remote pipe. So the electrons are giving up and the electrons are received in the steel pipe which I am protecting. There is a positive current which happens from the anode to the pipeline through the earth or water, which is actually my electrolyte or the medium. So this is a very interesting schematic diagram which shows me how I am passing impress current in a location where I am protecting my original member to become cathodic and I am putting a sacrificial anode to make it an anode, therefore the impress current method is being used for cathodic protection. Alternatively, you can also use sacrificial anodes where an external member or a material like aluminum, magnesium, zinc are connected externally to a pipe or a steel member or a surface which is to be protected. So the steel member has to be deliberately made as a cathode and the alternate member which I am now introducing in the material is an anode, and the anode sacrifices, therefore it gets corroded and it is protecting alternatively the cathodic member which is the original steel member of a material. Remember, this method is effective only when you apply this for members which is completely immersed, because this method requires a bulk contact of electrolyte for the process to activate very seriously. The main advantage of cathodic protection over the other forms of anti-corrosion treatments are the following. It is applied simply by maintaining a DC circuit. Its effectiveness may be monitored continuously. It is very important, ladies and gentlemen, all the cathodic protection treatments which we saw in the recent lectures or the slides, is important that they should be monitored continuously, because you have to record the amount of electronic flow or the electric flow happening between the terminals of anode and cathode, which will tell you what is the rate of effectiveness of a protection treatment. So constant monitoring of electric supply happening between the cathodic protection or the protected member and the sacrificial anode is very important in such control mechanisms. So it is very important that the monitoring happens effectively and it is continuously happening. The cathodic protection is commonly applied to any coated structure to provide corrosion control to the areas where the coating may be damaged. For example, you have a member which is completely coated which lies in atmospheric and splash zone. There is always a tendency this coating may get washed off or leached off because of the chemicals present in the sea environment. So if you suspect that kind of, let us say, erosion happening on the steel material surface, then you can use this kind of protection in those zones which is possible that you can have corrosion very actively taking place. If the coating is likely to get damaged, you can use cathodic protection in those areas also. It may be applied to existing structures to prolong the service life. That is a common phenomena what people use. Nowadays cathodic protection techniques are also implemented in the design stage itself. Structures that are commonly protected by cathodic protection are the exterior surfaces, of course. The examples are the following: can use it for pipelines, can use it for ship hulls, can use it for storage tank base, can use it for jetties and harbour structures, can use it for steel sheets, tubular and foundation piles. Of course, offshore platforms floating in subsea structures are common examples where cathodic protection is very largely deployed in the recent past. Cathodic protection is also used to protect the internal surface of certain members. You can use large diameter pipelines and you can protect the internal surface from corrosion using this technique. You can also use the ballast tanks and products like this in ship tanks to protect it from corrosion. You can also use large storage tanks which are essentially used for storing oil or water for corrosion protection, and of course water circulating systems which are subjected to lot of differential heat or temperature variation can also be used, can also be deployed by this method to protect them from corrosion. Now let us look at the requirement of a cathodic protection system to metals in an electrolyte. A galvanic system, if you prefer to use, requires the following. It requires a sacrificial anode, it requires a direct welding to the structure or a conductor which connects the anode to the structure, and of course a secured and a minimum resistance connection between the conductor and the structure is to be ensured, and between the conductor and the anode is also to be compulsory ensured to make this kind of protection more effective. An impress current system of course alternatively requires the following. It requires inert anodes, which is nothing but cluster of anodes connected together often in a backfill which are called as ground bed. It of course requires an external DC power source, an electrically well insulated system, the minimum resistance and it secures conductors between the anodes and the power source. Ladies and gentlemen, in the present lecture we discussed about different methods of corrosion protection, cathodic protection, sacrificial anode, etc., different combination of metals which can be used as coatings, sheathings, etc., to protect the metal surface from corrosion. We will discuss more in detail about the equipment types which have been used for this treatment in the following slides. The equipment types which are commonly used for galvanic anode or galvanic protection systems are magnesium, aluminum and zinc. They are available in terms of rods, big blocks or wire forms which can be wounded around the member. They are also cast around the steel inserts to enable their fixing. These inserts are then connected to the structure. They can be either bolted or welded. When you talk about the source of DC power, which is a vital part requirement in case of impress current method, the rectifiers with transformer units in conjunction with an existing AC supply can also be used, or alternatively can use either diesel or gas driven alternators. In remote areas, power source include thermoelectric generators, solar or wind generators which are commonly and widely deployed for generating the required DC power for impress current methodology of cathodic protection treatments. You can also do corrosion protection in the design stage itself. You can choose the system to be galvanic, or you can introduce a sacrificial anode in the system in the design itself, or you can plan the layout for an impress current system. At times very commonly a combination of both of them are used in the design, but most importantly care should be taken to avoid interaction between these two methods. Galvanic systems are effective for small, well coated, low current demand structures. On the other hand, they offer excellent localized protection, whereas impress current systems are recommended for large complex structures. Remember, ladies and gentlemen, the suitability of these two methods depends upon whether you are requiring an intensive localized protection or requiring a generic large surface area of protection. So you can use either a galvanic system or an impress current system for corrosion protection methods. In North Sea, very commonly where maximum platforms are deployed, it was found that cost effective method proved to be galvanic protection against the large uncoated platforms. Since the cost of coating and maintenance was very high, people preferred to use galvanic protection techniques in Gulf of Mexico or in North Sea for majority of the platforms. Galvanic systems are easy to install and there is a robust system. It requires no external power source, so it is considered to be one of the main advantage of this kind of method. It provides protection immediately on float out of the structure. So the corrosion protection by means of galvanic protection is very effective and more or less instantaneous for a structural system. Whereas compared to sacrificial anode or galvanic system, there are advantages. It is very simple to install, no external source power is required, localized protection is very highly effective and immediately available on float out and less interaction with the neighboring structures. When you talk about disadvantage of the system, the current output available is relatively small. Therefore, monitoring a galvanic system for effective corrosion protection is very difficult unless otherwise your monitoring system is highly sensitive to record small variation in voltage. Flow of electrons depends on the electrical resistivity of the electrolyte. Changes in the structure, that is deterioration of coating, demands more and more current and hence more sacrificial anodes. Therefore, sometimes this method proves to be expensive. Alternatively, if we talk about impressed current systems, it is having certain merits as listed below, can supply relatively a larger current. Therefore, effective monitoring of control mechanism is highly feasible if you use impressed current mechanism. It is able to provide high DC driving voltages and can be used in most type of electrolytes. It is able to provide flexible output, therefore it may accommodate respective changes in the structural members. But there are some demerits of the system. For example, intensive care should be taken to minimize the interaction with other structures because it is uniformly available for larger protection surfaces. Therefore, interaction between the structural members and elements is also highly feasible in this kind of protection systems. No AC supply, only alternate power supply is required. Regular maintenance and monitoring is very important in this kind of protection system. Thank you very much. In the next lecture we will discuss more about the corrosion protection techniques and the monitoring of them. We will also see this program in detail in the next module where I will discuss about repair and rehabilitation of marine structures using advanced techniques. Thank you.